Hello friends, welcome back to my YouTube channel, and in this lecture I'm going to talking about recursive translation networks. Here is recursive transaction network. So let's start our topic. This section describes a more powerful technique for defining language. The surface form of textual language are typically infinite set of string to define a language. We need to define a system that produces all string in the language and no other string. The problem of associating meaning with those string is more difficult. We consider it in later chapter. A recursive transaction network is defined by a graph of nodes and edges. The edges are labeled with output symbol. These are the primitive in the language. The node and the edge subtraction provide the means of combinations. One of the nodes is designed the start node identified by an arrow point into the node. One or more of the nodes may be designed as final nodes. Uh, one sorry a string in the language A string is in the language of there existing some path from the start node to a final node in the graph where the output symbols along the path edge produce the string. uh, Figure 2.1. Here is figure 2.1. So let's talk. Show a simple RTN with three nodes and four edges that can proceed from different sentence starting at the node mark. Now there are two possible edges to follow. Each edge output a different symbol and lead to the node marked verb. From that node, there are two output edges, each loading to the final node marks as since there are no edges out of as this and the string hence the RTN can produce a for string corresponding to the four different paths from the start to final node. So, alias jump, alias run, bomb jump, and bomb runs. Mm, So, next, the expressive power of recursive translation network increase dramatically once we add edge that from cycle in the graph. This is where the recursive in the name come from. One graph has a cycle. There are infinity many possible paths through the graph. Consider what happened when we add the single and edge it to the previous network to produce the network shown figure 2.2. So this how many nodes are needed for recursive transaction network? The pro does exactly 8 settings. How many edges are needed for a recursive transaction network that can produce exactly 8 settings? Give a whole number. How many edges are needed for a recursive transaction work that can produce uh, exactly setting. Okay, and example here is example. Draw a recursive transaction network that define the language of the whole number 0 1 2. Now we can produce infinitely many different settings. We can follow the and add the back to noun node to produce string like alias random. Okay, so I'm going to end this my lecture. So this lecture was about recursive translation networks, and So I hope this video will be informative for you. So goodbye, take care.